Hey guys, I was just real quick gonna go through and show you, make two videos real quick. Actually, I'll just do it in one where we talk about going through and looking at how do I get Desmos to write an equation for me for linear and exponential. How do I know which one's a better fit? And then the other part I'll go over is how to put mean, median, and mode for data sets in there. So let's say I want, I've got an x and a y. I want to write an equation. It could be linear, it could be exponential, but I'm not 100% sure. So first thing I'm going to do is build a table. So like, for instance, a lot of times you'll get data sets that say start in 1930. Always make your first point 0 and then whatever it is. So like, let's say I'm making up some numbers. So don't stress over where these came from. But if, for instance, it was 1930 and the next year I saw on the table is 1935, then I'd want to make my next one 5 because it's 5 years later. And I just put in some data. I'm going to put in a few points. Okay, and this is just that I'm making up off the top of my head. So in order to see the data where it's graphed, you click this zoom fit button down here and it'll move your graph to exactly what you want to see. So here are the 4 data points I see. Okay, right now I'm not sure if it's linear or exponential because it could be either based on what I've come up with. So what we're going to do is run a regression to figure out which one's the better option. So remember, when you're running a regression, you can't just do y equals mx plus b, okay? All that's going to do is give you some random sliders that you can play around with, okay? Instead, what we have to consider is the fact that our table is built on x1 and y1. So the first thing I'm going to change is make that x1, make that y1. You'll notice that it panics a little bit because we can't use an equal sign. Equals means, hey, this is going to be an exact problem, and we've talked about how this is an approximation of the best fit. So I'm going to change this to our little approximation symbol, okay? And you'll see we have our equation written for us, y equals mx plus b, where m is negative 2.427 and b is 63.7. Our r squared value is 0.884, so that's a pretty strong correlation. Remember that strong correlations are either positive 1 or negative 1. But there's a potential that maybe an exponential is a better model for this. So the only thing that we need to change there is the structure of our function. So I'll do y1 is approximately a times b to the x1. And you'll see that I've got my a and my b, and my r squared value is 0.863. What that means is that this is stronger than, or sorry, the linear is a stronger regression than the exponential. So it's actually a better model for linear. So I actually don't need my exponential, but this is a good confirmation that linear is a better choice. Most of the time in the problems, from what I've seen, they tell you linear exponential, so you don't have to guess. I'm going to turn off this exponential, just exit it out, and I'm going to put in the equation that this wrote for me, which was 427x plus 63.712. You'll see it kind of graphed right on top of that black line. If for some reason I want to predict a future value, the way we talked about doing that is by going up here, turning that into a table, and let's say I wanted to know what it was 10 years later, or let's do 20 because I've already got 10 years later. So 20 years later, then I just put the 20 and it shows me that this is the value that I would have. So this is how we build equations. It would work similarly with the exponential. You just have to type in your exponential version and get there as well. Couple things to remember about exponentials in general. Remember, a is the starting value, b is the value you're multiplying by. Okay, the next thing I'm going to go over real quick is how to do mean, median, mode, standard deviation, and talk about that real quick. So remember, to build a set of data, I got to give it a name. So any letter is really good. I would stay away from X and Y. I just don't trust them in Desmos because they've already got assigned understandings. So like, let's just say R, for instance. I build a set that says R equals, and I use the square brackets. And I say R equals, well, does R equal 2? Let's see, 4, 8, 19, 35, 94. Okay, let's say that is my set of data. Notice that automatically it tells me I got 6 elements because I'm supposed to have 6 numbers in there. So if I were to do a problem and I knew I had 10, but for some reason I only see 9, go back and look and see which one you maybe missed. Then it's really pretty simple as far as like telling it what to do. I say mean of R, median of R, and standard deviation of R. And remember, if you can't remember what to type in, all these are under functions, under stats. So standard deviation, mean, median, those are the big ones that you'll need. The big thing about standard deviation is remember that smaller is better, because if you have a smaller deviation, that means your data is less spread out and therefore your data is more consistent. The other thing that might be super helpful real quick is to talk about the skews. So skewed data distribution, what that looks like. So like, here we go. See, we use left, right, and center, not those values. Here we go, here's a good picture. So if you can see here that we've got our symmetric distribution, which is our normal because our mean and our median are pretty much right on top of each other. We have our right skewed distribution, which tails off to the right, and the mean is to the right of the median. And we've got our left skewed distribution because it tails off to the left because our mean is to the left of our median. And you can do that by comparing actual values, or you can do that by actually looking at the graph itself, or maybe a histogram or something like that. Here's another kind of comprehensive picture, right? If it's balanced left, it'll have a tail out here. If it's got a tail out here, it's to the right. And if it's like the picture you see here, it's symmetric. The only other thing that might be of benefit for you in Desmos in general is, like, let's say you're solving an equation and you have, because I saw a lot of people asking questions, if I have 2 equations and you're wondering what the solution is, so here are my 2 equations. I'm going to make this minus. Remember that the thing you're looking for is the intersection. So that's what I would be looking for if I'm looking for a solution. If they don't intersect, they're parallel. If they do intersect, they have one solution. And if it's the same exact line, then they have infinitely many solutions. Trying to think if there's anything else that's super, super important. You can also check parallel and perpendicular on this one, just to point out how I know certain things are parallel or perpendicular. If I'm looking at this to find a right angle, if you hit zoom square, if it's not already done, you'll be able to really see a tight right angle right there. And literally, if you held up your paper to that corner, you would see if it was a right angle or not. I'll also say this, you can always just type in coordinates to see if it goes through a coordinate, right? If, like, I knew that my line was supposed to go through 2, -3, and you see it doesn't, that would be a problem you could check out. So just little things like that might be helpful as well. If you have, obviously we know how to put in linears. I will say stuff about sliders, like just like the sliders we play with on Gizmos. If you want to set up sliders on your test and be like, I'm just trying to figure it out, it'll remind you of some things, right? So like if you don't remember what M does and you don't remember what B does, this is a great way to remind ourselves during our exam. Same thing, maybe even more important, because exponentials were the thing we didn't spend quite nearly as much time on those as we did linears. But if I take my structure here, right, and this is my exponential, break that out real quick, you can see that this is making it increase and decrease much faster. This is the number where I'm starting, right? So you see it, I'm at 3.9. It just so happens, I'm going to turn off these linears because they're in the way. And that quadrant, right? You can see that 3.9. And then as I mess with that, you can see that change. And then this is the thing that makes it increase or decrease much faster. So those are good ways to double check any knowledge that you might be concerned about if you don't remember what those values represent. I'll also say this for quadratics. If you have a quadratic, like for instance, I didn't nail that one quite. Let's just use the one I had. If I'm looking, remember, if I'm trying to find roots, x-intercepts, or zeros, those are here. Those are your x-intercepts, right? Whereas if here's a different equation. If I'm trying to find y-intercepts, remember y-intercepts are present here. There's x-intercepts. And this point is your vertex. So just make sure you know the vocabulary well, right? Y-intercepts hit the y-axis. X-intercepts hit the x-axis. And the vertex is that max or min. If I make this negative, remember everything flips upside down, okay? So I still got my y-intercept, my vertex, and my x-intercepts. I think that's about it. I think that's good enough, a good quick review to watch maybe before you come strolling into the test and watch tonight as well.